Hello everyone, welcome back to the one more session of multimedia systems. Let us continue our discussion with the topic called the data compression. Before starting into the new session, let us recall what we had discussed in the previous session. During our previous session, we had discussed about various coding techniques like the arithmetic coding and also various other basic techniques with respect to the compression. We had discussed about the JPEG, its origin, its history and why it was so important with respect to any of the coding formats with respect to still images. We had also discussed about the JPEG modes, the three important modes in association with the combination of all the three, the fourth one. And we had discussed about the expanded lossy, the DCT-based mode, that is the expanded lossy with respect to discrete cosine transformation based mode. We have also gone through the lossy mode of the compression. Finally, we had illustrated with taking an example and also the steps with respect to algorithm, the working principle of a JPEG with an example. Let us continue our discussion. In the next discussion, we will be talking about the next mode of compression, that is the hierarchical mode. When we talk about the hierarchical mode, it is the important technology which has been introduced with respect to compression of still image that's been used in this mode. So the hierarchical mode can either use one of the lossy DCT algorithm or an alternately it can use the lossless algorithm technique, means it's a combination. Okay, it can make use of a lossy or the lossless compression techniques in its prescribed format which has been needed at that instance of time. The main feature of this mode is to encode an image at different resolution. That is the key point, whereas it supports the compression at different resolution. This is the key factor that makes the hierarchical mode of compression an important one. When we talk about the digital image, it is first reduced by a factor of 2 power n. So in the hierarchical mode, what we do? We take up a digital image and reduce it to a factor of 2 power n, and then we work on the compression. Then the original image is reduced to a factor of, now this image is reduced to a factor of 2 to the power of n minus 1. So why we are using it to 2 to the power of n minus 1? We have seen the explanation, the importance of 2 to the power of n minus 1 during the understanding of the working principle of a JPEG working. So here 2 to the power of n is the format in which the image, digitized image is taken. Then it's been reduced to 2 to the power of n minus 1 factor vertically and horizontally, means the image has to be reduced horizontally also vertically. So both has to be done. Then the previously compressed image is subjected from this, or the, what do you mean by subjected? Means put forth for the subtraction, means previous compression image is subtracted from this new image and the result is once again compressed. This process is successively repeated, means generating the image as 2 power n and again reducing it to 2 power 2n minus 1 and subtracting it from the previous generated image, and this process continuously goes on until the resolution of the image is completely compressed, means repeated, the process is repeated until the full resolution of the image is completed. Means we continue this process until full resolution of the image is compressed. So this is about the hierarchical mode. So when we talk about the hierarchical coding, it is computationally intensive and requires considerably a lot of storage space. This is one drawback we can say. Why it is so intensive means, here we are taking the image into 2 to the power of n and reducing it to 2 to the power n minus 1 factor, both vertically and horizontally, and subtracting this with the previous image, that is 2 to the power of n, and new image is obtained, and that is subtracted with the 2 to the power of n minus 1, and this process goes on until the full resolution of the image is compressed. This is the key part, and during this process, because it is a lengthier task, so it requires huge amount of storage space. The advantage here is it is compressed. Image is available at different resolution, means we can fix to what amount of resolution we want. Till then we can keep going with the compression. This is the one of the advantage of this hierarchical mode. What we can do is, means here we can stop the compression until the required resolution is achieved, means the desired level of compression with respect to the resolution can be fixed up in this compression technique. So this is called the hierarchical mode of compression. Next, till now we were discussing only about still images and a bit of the motion images, that is motion JPEG was discussed. Now we will look into one more part, that is even with respect to the compression in association with the video compression, that is digital video also. We have two methods, H.261 and one more is the H.263 compression. So why are they associating the two different compression with a single title, means it is almost similar, but H.263 is a bit improved version when compared to H.261. Now let us discuss with this kind of compression. It is the oldest digital video compression. The first point, it is the oldest one. And mainly this kind of compression is associated with the video compression. This is the important point that we need to consider here. Till now we were discussing mainly about the still images. Now we have coming up to the compression with respect to video also. Now H.261 was developed and it was initiated, means the initial development or the compression technique H.261 was initiated by CCIT. CCITT. What does CCITT means? It is Consultative Committee for International Telegraph and Telephone. I will repeat it again. The compression technique of H.261 was initiated, means it was started, or this technique was initially developed by CCITT, means Consultative Committee for International Telegraph and Telephone, in the year 1988. So it is a very oldest one, it is not a new one. So we need to understand from this, video compression was already there during the 90s itself, 1988 itself. So now what is this? So next, when we look into this technique, finally it was adopted, means it was approved, or finally it was used, or the company which started to make use was ITU-T. ITU-T. What did they do? Here what does ITU-T stands for? International Telecommunication Union of Telecommunication. The word telecommunication is repeated again. I will repeat again, International Telecommunication Union with respect to the telecommunication. What they do? They adopted this kind of technique in 1990s. Look at this, the gap. So from 1998 the process was going up and improvements was done, and finally in 1990 ITU-T finally approved it and adopted for using this kind of H.261 technology with respect to the video compression. And finally, when you talk about H.261 was developed for real-time processing during encoding and decoding. This is important. Till now we were looking into the compression with respect to encoding and decoding during the off time. Means whenever we want, we used to do it in the off time, and whenever we want to require it retrieve back, we used to decode it. But now in a real time we are talking in this one, because we are talking with respect to the video compression, and this standard was designed for two main things. It was designed mainly for two things, for two standards, when we can call it as standards. The first one was the video phone. Means the phones which had the options of video calling and video technology in the phones. For that they use it, because there we have a real time encountering with respect to the video data streams, and it was also important for video conferencing. So this technology was mainly focused for designed for two kinds of standards. First one was the video phones and also for video conferencing. This audio visual service, we don't call it as only audio service. Here this technology also accomplished with a compression for both audio as well as the video. So this audio visual services are used with low bit rate. This is the key point with this technology. So I underline this. This technology uses the low bit rate, that is ISDN. What is ISDN? Integrated Services Digital Network over the telephone line. So this is very important with respect to the telephonic conversation of videos and video conferencing, because there we encounter real time video exchange, video data stream transferring. So in those cases H.2.61 plays a major parameter or major factor. So this is the importance of H.261. Now what is H.263? Let us look into it here. It is a provisional ITU-T standard published in 1996. See here, even this standard, the ITU-T was adopted in 1990, whereas H.263 was mainly adopted by the same committee ITU-T during 1996, just to replace for some kind of application. What are those some kind of application? Some kind of application needed some of the improvements with respect to this technology. So only with a slight improvements with respect to the H.261, H.263 was developed, and it was mainly associated for the particular kind of application with respect to compression. So which is similar with the improvements, means all the working principles and all the technology used are similar with respect to H.261, only with some improvements. Means few improvements were associated here, and like H.261, it was designed for low bitrate transmission. Means here it's the same, and again here it's a same here. Low bitrate transmission was assigned here, or it uses low bitrate like H.261, but used for wide range of bitrates. Here the bitrate transfer was low, but it was limited to a particular range. But here what was the advantage that to overcome H.261 was, here it was used for wide range of bitrates. So with respect to the efficiency of video compression, it is best technique available today. So either H.261 or H.263 is the best one, that is specifically for the wide range of bitrate transmission, and here the range is limited, but both the technologies are same, as only with respect to here it's limited to a particular range. Here we have wide range of application that can be used with respect to bitrate for compression of video technology or video data streams. This was about the H.261 and H.263, and let us continue our discussion with both the things. Now here there is one more differentiation both the technologies use. This method defines two picture or video formats. What are those? So it might be either H.261 or H.263. It uses two picture or two video formats. What are those? We will see one by one. The first one is the CIF. The second one is QCIF. So what is CIF? CIF stands for Common Intermediate Format, whereas QCIF stands for Quarter Common Intermediate Format. So how to bifurcate or how to analyze these two? So we can analyze these two with this chart. We will write this. The first one is the video format. Here we have CIF and next we have QCIF. Next parameter would be luma. Second one is chroma. Whereas here in CIF, when we talk about a luma, it is 352 into, which we are talking about resolution, because here the resolution with respect to low bit rate is the matter, 2 into 288. Okay. And what about the chroma factor here? 176 into 44. 144. So when we talk about a QCIF, it is the same value here with respect to chroma, 176 into 144, whereas the chroma value here is, what is the chroma value? It is 88 into 72. Now what do we get from this? And from this, when we talk about the luma and the chroma, luma stands for the luminance and chroma stands for chrominance. Luminance is nothing but brightness in the image, whereas chrominance is the color in the image. I will repeat it again. Luma stands for luminance, chroma stands for chrominance, and luma means it is the parameter that is associated with the brightness of the image, and chroma is the chrominance, the factor that is associated with the color in the image. Then what would be the bit rate of data transfer? It would be in megabytes per second usually. Okay, we do that. So here when CIF we have 36.5 and whereas in QCIF it is 9.1. Now look at this. So we were talking about H.261 and H.263. So both uses the similar kind of modes, that is CIF and QCIF, whereas CIF has a luminance factor of 352 into 288 and the chroma factor, that is a chrominance of 176 into 88, and the bit rate that is achieved here is that with respect to the uncompressed data it is 36.5, and when we talk about a QCIF it is 176 into 144 the luminance, and the chrominance factor is 88 into 77. Look at this, there is a similarity between these two. The chrominance of CIF and the luminance of QCIF is similar because QCIF is the quarter CIF. So where you take the quarter portion of it and then we start with respect to the again. This is the primary intention to understand H.261 and H.263. And when we talk about the next topic, we'll go with compression includes now H.261 compression includes some kind of combinations that needs to be used. So what are those? We'll see that. I'll write it in the bracket, combination. So what combination is directly used with respect to H.261? First one is inter-picture prediction. So what we do here when we talk about the inter-picture prediction, here we remove the temporal redundancy. What do you mean by temporal redundancy? If two frames have same pixel value, then one frame is compressed. Sometimes you might be seeing when we talk about the capturing of video, a still image or a particular video conferencing, the frames are there and there is no changes with respect to one frame to another. Okay, in that case means the pixel value of different frames are similar or two or more frames are similar, we predict it saying that the next frame should be similar until the next change. So what we do, we compress it. So this is called inter-picture prediction, means we predict between one frame to another frame assuming the in between frames are similar, so we compress it. When we compress it, that's the storage size has been totally reduced. So that is about inter-picture prediction, which is called removal of temporal redundancy. Second one is transform coding. So when we talk about the transform coding, it is nothing but remove spatial redundancy. What do you mean by spatial redundancy? It removes the duplicate frames. Sometimes during the process of video technology, so there might be a frames which might be a duplicate one, which is exact replica of a particular frame. Here we are not talking about the pixel values, whereas here we were talking about the pixel values. Here we are talking about the duplication of a particular frame. So in this case, we remove the spatial redundancy, means removing the duplicate frames which are similar already present. So we remove it. By removing, what happens? The duplication is removed, thereby reducing the size, means the compression is achieved. And third one is the motion vectors. . So when we talk about the motion vectors, what is it here? Here it is motion compensation. What do you mean by compensation? Alternatives. Instead of this one. Instead of taking this, take this. It is compensation. Here what we do? Here we match the current frame with the previous frame in order to find the continuous motion. I will repeat it again. Here what we do here? We match the current frame with the previous frame in order to find the continuity. This is called the motion vector. So these are the three combinations that are used with respect to the H.261 compression. Next. Next we look into the design details, that is H.261 compression design. So when we talk about the design details, it mainly consists of three elements. So what are those three elements? We will go one by one. The first one is the prediction. So here it is almost the combinations detailed explanation is happening, because we know that combination, what are the three combinations just now we discussed. So those details has been explained with respect to the design. So we will go to it one by one. What we do in the prediction? In the prediction, it consists of, where image consists of blocks that mainly consists two kinds of frames. What are those? Those frames are inter and intra frames. During the process of prediction, we would be able to find two kinds of frame blocks. One is the inter frame and second one is intra frame blocks. So when we talk about the intra frame block, it mainly supports I frames. This supports I frames, whereas inter frame supports P and B frames. Okay. So we find blocks of frames which consists of inter frames and intra frames, where inter frame supports P and B frames, types of frames, whereas intra frame supports I frames. So when we talk about the intercoded blocks, they stand alone, means they are individual. Here what we talk about this, that's why we call it as I frames. These are individual frames. Whereas intercoded blocks are totally based on the difference between previous and current frames. Means here so because we have two things, one is P and B, which provides the difference between the previous and the current. So this is the current, what was the previous one. So we can able to find or assess the continuity in between. So this is about the first one, that is the prediction. When we talk about the second one, it is the block transmission. I will write the second one here. So what we do here in the block transformation, each block is compressed into 8x8 blocks and processed by DCT function. Very clear, we have been doing this even in a JPEG. So what we do here, we convert it into 8x8 block and apply the DCT process. So what is the DCT? Discrete cosine function or discrete process is applied on that 8x8 blocks. So what kind of 8x8 blocks are supposed to be used? We are supposed to generate 8x8 non-overlapping frames blocks. So non-overlapping blocks has to be done. So in the finally we have the third step in the design, that is called quantization and entropy coding. So what we do here? Here we compress a range of values into single quantum values. So this is the key of this, because we have wide range. I am not only talking about H2.61, I am also talking about H.263. So both are similar almost. So here it supports wide range of values. So now when we have a quantization, we compress the range of values into a single quantum value, and entropy coding means usually it is a lossless, is employed like the Huffman coding here. So here we use the entropy coding, which is lossless. So finally, when we talk about the H.261 or the H.263, the compression design details, the total design details can be categorized into three main elements. The first element is prediction, where you find the blocks of frames. The two kinds of frame blocks are achieved, where first is the interframes and second one is intraframes, where interframe supports two kinds of frames, that is P and B frames, and intraframe supports I frames, which are called individual frames, where P and B frames provide the difference between the current frame and the previous frame in order to assess the gap, in order to find the redundancy, in order to find the continuity, in order to find the duplication. All these things are very much supportive with these kinds of frames. And the second one is the block transmission. What we do in the block transmission, we are transforming the image into a block of 8 cross 8 non-overlapping pixel blocks. So that process is applied. What process? DCT function is applied on that. When DCT function is applied, it is ready for the final process of compression. So in the final process of compression, it is a quantization and entropy coding. So what we do mainly, the main compression happens during this process, that is a quantization. Here we apply the quantization, means the range of values are totally combined or merged to a single quantum values, because these frames supports to assess those things. So we are able to find the range of values, we will combine those range of values, nearby range of values, into a one value, that is called single quantum, and also supports lossless compression. So this was about the H.261 and H.263. And finally, we need to know the advantage and disadvantage of this kind of compressions. Let us look into this. Advantages and disadvantages. Always, whatever the technology might be there, it has both advantages and some disadvantages in it. Let us look into the advantages and disadvantages with respect to H.261 and H.263 compression. First, we will talk about the advantages. When we talk about when we talk about the advantages, it is optimized for low data rate. This is the interesting one. We have seen that already with respect to the comparison, and strong temporal compression component is achieved. So that is a plus point here, means a strong temporal compression, means here we have a strong component with respect to compression. So we are using intraframes and interframes. So here compression is very strong with respect to the parameters that we have receiving with the prediction, and best works on the movies which have little changes between the frames. So this is a plus point, means if there is a frames which has very minor changes with respect to the contents. So those kind of moving pictures are best achieved with respect to the compression. So these are the advantages. When you look into the disadvantages, generally do not provide good quality. This is the one parameter that needs to be considered while compressing the video. So though we are having the compression achieved for the low bit rate, the quality of a compression is not good. This is the disadvantage, and does not play, means when the compressed data is put on a particular device with the lower end devices or a machine, it does not play properly. This has been practically sensed by many of the researchers. Means after doing a compression from this kind of technology, the compressed data, if we try to play those data or video streams on a lower end machines, it is not properly played. So that is said to be the disadvantage. So let us recall what we had discussed in this session completely. So in the beginning of this session, we started with the hierarchical mode. So we saw about how hierarchical is so important with respect to other combinations of lossy and lossless techniques together in order to achieve a good compression rate. We had started the discussion also with respect to the H2.61 compression. We have seen the H.263 compression also. Even we have seen the comparative statement or the comparison between the H.261 and H.263 compression technique. We also saw the two picture or a video formats, that is CIF and QCIF, and also their data rates with respect to the transmission. And we also saw about H.261 compression combination, what that is included in that, that is interpicture prediction, transformation coding and motion vectors. The same thing, the same combinations has been involved in the designs also. So when you talk about the design details included like the prediction, the block transformation, and finally the quantization and the entropy coding. And finally we saw the advantages and disadvantages with respect to the H.261 compression and H.263 compression. So during the examination, when there is a question asked for H.261 or the H.263, the same details can be added into the paper. So explanation can be achieved with the same kind of things because it has very minor changes with respect to both the things, except H.2.63 is supported for wide range of data streams. So these are the things that I had wished to discuss in this session. Thank you very much.